In the last video, we have had a quick look at what Transformers library can do for us. And one of the things that we have seen that it can do is, it can allow us to do inference much more easily than using the lower level deep learning libraries directly. And one of the abstraction that makes it possible is called pipeline. And in this video, we are going to take a detailed look at how we can use this pipeline abstraction for different tasks. So pipeline is basically a simplest high-level abstraction provided by Transformers library. It hides many different things that we need to do in order to use a model for any inference. Basically, when we are using pipeline, it automatically takes care of the things that we need to do manually if we are not using pipeline. Let's see what pipeline does under the hood for us to provide the simplest abstraction. So first of all, when we pass an input, that input has to be pre-processed. So when we are talking about NLP models, then the input has to be tokenized according to that model's specification. So different models will use different tokenizers. So the input that we pass has to be tokenized according to the model's expected token format. Okay, so that is the pre-processing step. And when we are using pipeline, this pre-processing, which is tokenization for NLP models, are automatically taken care by our pipeline abstraction. Then the model need to be loaded. So this is, downloading the model from Hugging Face and loading it in memory, right? So this part is also taken care by pipeline. And what is more elegant is, when the model is downloaded for the first time, it is cached locally, and from then on, the cached version is used. So this is going to save time for second and future inferences. And then it runs the inference. So it has tokenized the input that we have given, and it has also loaded the model. Now it sends those tokens to the model for inference. Then we get the output from the inference, right? So that output will not be readily usable. So in the post-processing step, the pipeline is going to change the outcome in a format that is suitable for us to use. So these are the steps that are carried out by pipeline abstraction under the hood. If we don't use pipeline abstraction, we need to carry out all of these steps whenever we want to do inference. But the challenging part is, these steps will be different from model to model. Okay, so you can't simply swap models when you are actually running an inference. But with pipeline, because it takes care of all these things under the hood, we can simply swap the model in our code, and the pipeline abstraction will take care of adjusting whatever that it needs to adjust under the hood for that particular model that we have selected now. Okay, next let's see an example of using this pipeline abstraction for sentiment analysis. But before going into the code, I'm going to show you how you can find this model in Hugging Face website, and I will also show you some useful information that you can find in the Transformers documentation section of Hugging Face website. Now I am here in the Hugging Face website, and I'm going to select models. Now on the left hand side, you'll be able to see all different tasks that are supported by the models available in Hugging Face. And the task that we are interested in is something called text classification. So if I scroll down here, we'll be able to see that we have text classification here under the natural language processing section. So what I'm going to do is, I'm just going to select this as a filter. So once I have selected this text classification as a filter, you can see that the number of models have gone down on the right hand side. And here we can choose the model that we want to use. So I'm going to use this model called Distilbert, and this model is one of the trending model, and this is a good model for text classification. So I'm going to click on this model, and in here we have model card. Model card is basically all the information that you need to know as a user of this model. Okay, so it will include all useful information for you to decide whether this model is going to be useful for you or not. Okay, and in the top here, we can also see some useful information. So here it says this is the text classification model, and this is the filter that we have applied to select this model anyway. And then it also shows that it has transformer support, which means we will be able to use this model with the Transformers library. And you can also see that it has support for PyTorch as well as TensorFlow, which means we can either choose PyTorch or TensorFlow as a backend framework for inference when we are using this model with the Transformer library. Okay. And if you see here in the use this model section, we will be able to see an option to use this model using transformers. And this is going to give you a quick documentation and code that you can copy to use this model using transformers library. So if I select this, we'll be able to see that here that we can use pipeline for using this model, and we can also directly load this model if you don't want to use pipeline for any reason. And we have code for both of them. Okay. And you can also find similar information in another section of Hugging Face documentation. So if I go to documentation by clicking on this docs option here, this will show me a documentation for different libraries and other things supported by Hugging Face. And if I scroll down here, we'll be able to see transformers under core ML libraries. So if I click on this, it is going to take me to the documentation section of transformers library itself. And if you scroll further down here, you see APIs, and under APIs, you can see models. And here the models are categorized. So we have text models, vision models, audio models. And if I expand text model, we'll be able to see DistillBERT as one of the model here. So if you see here, DistillBERT is one of the model here. This is the same model that we have seen previously. And if I click on it, it shows me a detailed documentation about this particular model and how I can use this model as well. So here you can see that we have option to use it with pipeline, and we can also use it with auto model if you don't want to use pipeline for any reason. And we can also use this model from CLI if that is actually preferred way to use this model. Okay. So one of the things that I wanted to clarify is we have selected a model called DistillBERT. But if you see here, we are specifying something else as a model here, right? So this is because on here, what we see is called model architecture. We have this architecture called DistillBERT, but we have many different model weights and configurations that supports this architecture. We call them as checkpoints. So DistillBERT is basically a model, and the weights and configuration that goes with it is called a checkpoint. And for any given model, we may have more than one checkpoints. Okay. So, but when we are actually using a model for inference, we need to specify the checkpoint, not just the model architecture, because without the configuration and weights, the model cannot be used at all, right? So that is why we see something different here. So this model is basically model's checkpoint. If you want to know how you can find these information, like, what kind of checkpoints are available, you can find them from the models organization page. So each of these models will have an organization page. So in this case, I can find that here in the documentation itself. So if you see here, we have this DistillBERT as an organization. So if I go in here, we'll be able to see many different checkpoints. So this is one checkpoint and this is another checkpoint. So there are many different checkpoints available for this particular model, but for some models, there may be just one checkpoint. Okay. So if you have multiple different checkpoints, you can choose the one that is suitable for you. And one of the other things that I want to show you is this concept called task within a pipeline. So when you are using a pipeline, you'll be specifying the task that you are going to perform. Okay. So the reason for that is, depending on the task, what it needs to do under the hood will be different, right? So for that, we have many different pipeline classes, and each of them are specialized for a particular task. When you are using pipeline function, it is going to pick right pipeline class to instantiate based on the task that you are going to perform. Okay. So you'll be able to find all the tasks that are supported by pipeline in this page here. So this is again a documentation page for transformers. If you come in here, you can see base classes. Under models, you can see this option called what transformers can do. And in here, we'll be able to see all different tasks that are supported by transformers. We have audio-based tasks, we also have computer vision tasks, and we also have natural language processing tasks. And if you see here, under the natural language processing task, we have many different options. We have text classification, token classification, summarization, translations, and all these things. So If you want to see how to use pipeline for text classification, you can go in here. This is going to show you an example again. So this is actually showing a simple pipeline abstraction for sentiment analysis, and we are specifying task here. Again, the reason why we need to specify task is using this task, this pipeline function is going to decide what underlying pipeline class that it needs to use for inference. Okay. So if I scroll further down here, we can see this option called token classification, and this is going to have named entity recognition as the task. Okay. So, and because we have chosen this as a task, when this pipeline function is executed, it is going to pick the right pipeline class that is suitable for this particular task, and instance of that class will be assigned to this classifier variable. Okay, so that is how it works, and that is why we need to provide task. And each of the tasks will have a predefined default model. If you don't specify any model, so for example, if I go up here, if I don't specify any model for sentiment analysis, it is going to pick the default model available for that particular task. Okay, but if you want to specify some other model for some reasons, then you'll be able to override that by providing a model parameter. Okay, with that, now let's go to code and see this in action for a very simple sentiment analysis. Now I am here in the VS Code. First of all, to use pipelines, we need to install transformers library, and we also need at least one supported backend framework. Okay, so for that I have installed PyTorch, and I don't have GPU, so I have installed this with CPU only support. And I have also installed transformers library from Hugging Face, and with both of these installed now, I'll be able to use pipeline from transformers library now. So if you see here, I have a simple pipeline for sentiment analysis. I have specified task as sentiment analysis, and I have explicitly specified the model here. Again, I don't have to specify this model, but in my case, I want to explicitly specify this. And by default, it is going to use PyTorch as a framework. But if I want to change it to something like TensorFlow, I can do that as well. But in my case, because I have only installed PyTorch, I'm going to use PyTorch as my backend framework. Okay, then this is going to give me this classifier, and this classifier can take my input text. Okay, so when I pass this input text, what it is going to do behind the scene is that it is going to tokenize this according to the format that is supported by this particular model. Then it is going to load this model, and the loaded model is going to be used for inference. Then it is going to get some output, and that output is going to be further processed in a way that it is easy to interpret. Okay, so that is what it is going to do. Let me run this and see what happens. So when I run this, it is going to take some time to process this input, and it is going to tell me whether this is a positive statement or a negative statement. As you can see here, it has come back with a positive label with a 99% certainty. So this model thinks that this particular statement that I have given, which is today is going to be great, is positive statement with 99% certainty. Okay, and I can also use this classifier for batch inference as well. So if I want to do a bunch of text to be classified as either positive or negative, then I can do that as well. So in here, I'm just going to comment this, and I'm going to uncomment this. Here the classifier is taking list as a parameter rather than single string. Okay, so now if I run this, it is going to give me the sentiment label for each of these. So in this case, I'm expecting 3 different outcomes. So if I run this again, this is going to give me 3 different outcomes. As you can see here, it has given me 3 different outcomes. The first one is positive, second one is negative, and the third one is also negative. And all of them are around 99% certainty. So this is how you'll be able to use pipeline abstraction for either single inference or for a batch. Okay, let's now take a quick look at using this model directly without using pipeline abstraction. In this example, I'm using auto model and auto tokenizers classes provided by Hugging Face. Now I'm first loading the model here, and then I'm also loading the tokenizer. Then I am tokenizing the input here, and then I am actually running the inference here. So if you see, This is what pipeline abstraction simplifies for us. We don't need to do any of these steps manually, right? If you're not using pipeline, then this is what we need to do, okay? And this may be what you want depending on your use case. So Hugging Face provides both options for us. If we don't want to go down to this level, we can use pipeline abstraction. But if you want to go to this level for any reasons, then that is also supported by Transformers library. That is all I wanted to share in this video. I hope this is useful. Thank you.